In this question, we have a ball that's been thrown diagonally, which means it's not going completely horizontally or completely vertically. And what we want to do is we want to find the speed, the components that are going horizontally and vertically. So we want to find the speed upwards and the speed towards the right. So what we're going to do is we're going to use trigonometry. So first thing is to make a closed rectangle like this. Actually, you can see there's a triangle inside it. The thing that you're trying to break down and resolve is always going to be the hypotenuse. It always has to be. And in this case, what we're going to do is we're going to find the opposite part, which is these two, the upward part, and the adjacent, which is the horizontal part here. So we're going to use trigonometry. So we're going to use SUVAT. If we want to find the adjacent, the part that's right next to the angle, we're going to have to, and we have the hypotenuse, we're going to have to use cos. So cos is equal to adjacent over hypotenuse. In this case, cos 30 will equal adjacent, which is what we're trying to find, and the hypotenuse, which is 10 meters per second. So you get 10 times cos 30 equals adjacent. Okay, so this gives us, in this case, 8.66 meters towards the right. If you want to find the opposite, then we have, and you're going to use the hypotenuse as well, then you have to use sine. So sine theta equals opposite over hypotenuse. So sine 30 equals opposite, which we're trying to find, and over 10, so basically 10 times sine 30 is going to give us 5 meters per second. Okay, so this is something to memorize. If you're interested in the part that's touching the angle, like this part right here, right next to it, then you always have to use cosine. And if you're looking at the part that's opposite the angle, like this part here, then you always have to use sine. In this part here questions, I'm going to break these down horizontally, vertically, but I'm going to avoid using the SUVAT. I'm going to just try to jump straight to it. So here, I know this part is touching angle, so that's going to be 200 cos 40, because if it's touching, it's cos. In other words, if it's adjacent, it's cos. In this case, the part that's opposite, the vertical part, the downward part, is the opposite part, so it's going to be 200 sine 40. Okay, here, if I want this part here, that's the part that's adjacent to the angle, so it's going to be 12 cos 25. This part here, that's opposite it, so in other words, this part here, that's going to be sine 12 sine 25. Here, if I'm trying to find x, again, I don't need to think about it, it's the one that's right next to the angle, so it's going to be cos. So 70 cos 35. And of course you can type this into calculator and work it out, but I'm skipping that step. So here I'm interested in y, but y and this part here are the same. So in this case it's opposite part, so that's sine. So 50 sine 30.